Great. Thank you.
Okay. Thank you very much. I apologize for the hitch. I hope I'll be able to speak to the end. I had a power fluctuation that affected my internet. So I'm going to present participatory evaluation of climate smart bananas for enhanced food security and income. And this is a presentation on behalf of the CRISMABAN team. This is a team that is evaluating climate smart bananas. I'll talk about that. And so I'm presenting on behalf of the team, and I hope they are in the house. So I'll talk about some facts and figures, and I won't spend so much time on this because Professor Swinen already and Jerome already talked about this. Then I'll go to the CRISMABAN project approach and what is the respective roles of the consortium members of the CRISMABAN project, and then I'll narrow down to some the work we are doing in Kenya, where we are doing participatory gender responsive variety selection of the Narita hybrids that Professor Swinen talked about. Just remind us that bananas are the world's most favorite crop, not just in Africa, but throughout the world. And we have over 1,000 varieties, according to records, growing in 135 countries in the tropics and the subtropics. A total value of 155 million tons, although sometimes these statistics are debatable because most of the banana is produced and traded locally, so you may not have accurate figures, but we, according to statistics, it's a major export commodity globally with an economic value of $40 billion US, of which only 15% is exported and to the Western countries, and mainly the Cavendish types, with 85% being locally consumed in the growing countries. When we look at the banana, when you look at, I want to remove this one. It's giving me here. When we look at bananas in Europe and Africa, because CRISMABAN project is between African and European countries, we realize that in Africa, we are growing and consuming a high diversity of highlight and plantain and dessert bananas, whereby this is a source of household food security, domestic income, like Jerome has talked about, and specifically that these crops are traditionally a woman's crop in terms of trading, in terms of growing, and also in terms of marketing. But when you look at Europe, the bananas, when you talk about a banana, they think about the dessert variety, the Cavendish variety, and only a few varieties are consumed in Europe. Despite the great importance of bananas, we appreciate that production is still far, far below, the potential. And according to a publication by Professor Swinen, the green gold of the green gold, I saw that he talked about the production fluctuating at around 9%. That means there's a huge gap, and this is due to many constraints, diseases and pests, and also soil degradation factors, marketing constraints, especially in Africa, limited access to planting material, and continued cultivation of local low-yielding varieties. Diseases and pests are considered the overriding constraint to banana production, affecting different parts of the plant, and this translates into low yields. Of special concern is that climate change has disrupted banana production globally. Although there are arguments that rising temperatures may favor banana production because bananas are increasingly being grown into previously warm, colder places, the changing rainfall patterns, the droughts associated with climate change, floods, cyclones, and so on, all outweigh whatever gains could have been realized from the rising temperatures. And the other observation is that the diseases and pests have tended to increase, and we have new emerging diseases and pests coming up. And based on this, we mooted the CRISMAD project, which means Climate Smart Banana Projects. This is a multidisciplinary project, multi-country project, which uses a value chain approach, like the previous speakers have spoken about. This is whereby we involve the stakeholders in the whole research process, beginning from the lab, through the evaluation process, and eventually the purpose or the ultimate goal is to adopt climate resilient banana varieties that have not only improved agronomic traits, but they are also acceptable by the market and by the consumers. So this is the approach we are using to develop a more inclusive approach in the research pipeline to ensure that the products are acceptable, adaptable, and of market value. So the CRISMAD project has been in existence for the last 3 years, and it is implemented by partners from Belgium, that is KU Leuven, the University of Liège, and Ghent University. Ghent University being the overall coordinator, KU Leuven, where the phenotyping is being done, the University of Liège, where they're studying the microbial interactions with the bananas, and then at ICIA Spain, NARO, and Kenyatta University, where I am, we are evaluating the improved banana varieties in the field. So the phenotyping strategy at Leuven involves growing the bananas in what we call a banana container under controlled conditions, and testing the response of the bananas based on changing simulated changing temperatures, changing water regimes, and so on. And then these are tested in the greenhouse and in the field. So the banana container has, of course, offers more control. But when you test the material in the field in Uganda, Kenya, and Spain, we are talking about the more practical and more agricultural relevance. Then, so what is happening is that at Leuven, they are phenotyping the material that is in the ITC, the International Transit Center of Bananas. They do climate simulation in the banana container, and then they phenotype this, and they are looking at different things: evaporation, the rates of evaporation, light modeling, soil water content modeling, and temperature modeling, and then selecting those varieties and that are adapting to the changing climates, thinking about the current climate and the future climates. Then at the University of Liège, which is another partner of CRISMAD, is where we are studying the beneficial microorganisms and how the interactions with the bananas enhance nutrient uptake and also water uptake. So this is what is happening at Liège, where they are screening the bacteria, and so far, they are out of 50 isolated strains. They have identified 13 species, 7 bacteria, and 6 fungus. And these are being screened for stress tolerance activity. After this, the next objective at Liège is the assessment of bioefficiency of selected endophytic microorganisms. And they do both in vivo and in vitro application. And again, the idea here is to study the interactions between the banana plant and the microorganisms, and to see how well the microorganisms may influence nutrient uptake and water uptake. In Spain, the group in Spain, led by Maria, is scanning microbiota, the ones that have been, have been worked on at RIEH, and what they are doing there is to identify the most promising species and genera of the beneficial microbes now at the level of the field, not in the lab. So that's what they are doing. And then they do field evaluations. And so far, they have, the group has undertaken evaluations, morphological evaluations, phenological evaluations, product evaluation, and physiological evaluations. And they are focusing on the 7 varieties shown. There's the ABB varieties, the ABB, and the AAA varieties at the field, in the field. At NARO, as already explained, they are focusing on drought tolerance, and in this case, the objectives are as shown. And the issue here, if you look at the left side, you can see what devastation drought can do. And with all this devastation, we are not expecting any yield from bananas. And therefore, in NARO, they have done a survey in drought-prone areas. And what is happening there is to establish the effect of drought on farmers' livelihoods and to identify cultivars that farmers consider tolerant to drought. Now, the reason why we are talking about participatory evaluation is because it is all about farmers. What do farmers consider as drought tolerance, not just what scientists consider as drought tolerance. And in this case, 4 hybrids have been formed, have been multiplied, and they are ready for field evaluation in 3 districts in Uganda. 40 farmers will receive each 100 plants, hosting the evaluation plots with 20 farmers in each site. I believe the results will come out soon. Now, when it comes to the Kenyan intervention, our entry point is the fact that we realize that past interventions in Kenya have focused mainly on desert varieties. There has been a lot of work on banana research in Kenya, but focusing mainly on desert varieties. But now we realize there's increased awareness of the nutritional value, and there's high demand for both cooking bananas and plantains. The other observations we have had in Kenya is that there has been preference of bananas over traditional cash crops, especially due to failure of the staple maize crop, due to drought, and also due to diseases and pests like the leaf necrosis and all that. There has also been a major shift to commercial banana farming, and currently there are exports of desert bananas from Kenya. So there is a great interest in bananas. But at the same time, we also observed gender shift in production and marketing. While traditionally bananas are women's crops, the moment that bananas have turned commercial, we realized that the men now get more interested, and in some cases, there have been documented intra-household conflicts leading to domestic violence in some cases. So what we decided is that we need to address these issues. We need to focus more on the cooking bananas. We need to also think about the gender issues as we introduce the varieties. And it happened that we are aware about the Narita hybrids, and therefore for us, we are concentrating on evaluating the Narita hybrids in Kenya. And our participatory approach involves, firstly, stakeholder engagement and mapping. And we are working in 3 counties. These are representatives from 3 counties. We started by engaging the county governments, and then taking the officers of the county governments through a stakeholder mapping exercises, so that we understand who are the major stakeholders and how to involve them in the next stages, and also creating awareness about the new Narita hybrids. So we are, I really don't know how do I get out beyond this, remove this from me. Anyway, so we are doing participatory variety selection of the Narita hybrids, and the process we are using, as we say, we need to involve the farmers throughout the process. So we bring the farmers to our labs, we explain the whole process, we do demonstrations we are going to do demonstrations in the counties we haven't done already. We are going to have farmers pick the preferred varieties based on agronomic traits and sensory qualities, and then we shall establish the Narita hybrids on their farms, and hopefully at the end of the day, we can select the varieties that the farmers will have chosen. Coming now to what we have managed to do, we have been able through the collaboration with the IITA and the assistance from VIB and Professor Swinen, we were able to import Jamprasim from ITC in Ibadan, Nigeria. We imported 25 Narita hybrids and 14 Peter hybrids, and these have already been propagated at Kenyatta University. And during the same process, through the CRISPR band funding, we were able to establish a laboratory from scratch and to multiply the Jamprasim in our laboratory, and also to train a full-time technician who is doing this work, and I think he's in the house this afternoon. The next phase is we have done greenhouse and farm establishment successfully, as you can see, all the way from in vitro through the hardening process. And currently our plants have bunched, and we are really excited about that. The initial intention was to have demonstration farms at the counties, but because of COVID-19 lockdown, we decided to establish the plants in an experimental farm at Kenyatta University, as I said, of 23 Narita accessions, and where we are collecting data and also bringing the farmers to visit the facilities and see what is happening, and also participate in the selection. So what we are doing now is to take data and to observe the Naritas in the experimental farm in KU. And what I can report on a preliminary basis is that we have observed obvious phenotypic variations in terms of the duration to flowering, the duration to bunching, the number of suckers, new suckers, the height of the plants, and so on. Very obvious phenotypic variations between the Narita hybrids. So we take data periodically. The first time we took after 100 days, then after 150 days, and we have continued to do that. So we have been assessing, looking at from our own perspective, comparing the Narita hybrids in terms of the height, the number of leaves, the stem guard, the number of suckers, the leaf, all those agronomic traits. And the idea is this, that when it comes to the farmers, they also have their own agronomic traits that they look for, depending on their use. Those that are also involved in livestock farming, they will prefer the bananas that have a bigger stem. The women farmers may want shorter plants, and so on. So this is what we are observing. As of last week, this is the data we took on the number of functional leaves, the number of sword suckers, the number of pupa suckers, and the plant girth at 1 meter level. I dare say that this data is yet to be properly analyzed to be able to compare what we are observing with what our partners in Uganda and Tanzania are observing. In terms of bunch formation, we have also observed that there is a clear phenotypic variation with Narita 6 being the earliest variety and Narita 1 being the slowest variety. But again, this has to be statistically proven when we do, we plant out more materials. So far, I can say that we are finding Narita 4, Narita 13, and Narita 18 as the best performing, but this again has to be, confirmed. Now, when it comes to the rationale for gender integration, we, as I said, globally, we know that women provide 50% of the agricultural labor force, and they're in charge of domestic food and nutritional security. However, they face serious gender biases and gaps in access to productive resources, and they are also disproportionately affected by production constraints, and especially climate. Women are less recipients of climate change. And this restricts their participation and also the participation of the youth in agricultural value chains. So the CRISPR project also aims at ensuring gender integration in the project to ensure that all members of society are benefiting from, or are benefiting, in the output and of the project. So we appreciate that gender knowledge has potential to mitigate the negative gender consequences. As Liv indicated earlier when we started, scientists may come up with with good products, new technologies, that ensure higher productivity and more income. But we have also observed shifts in gender roles, as I said, when banana become a commercial crop. And when now there are conflicts in terms of benefits allocation, when there's money coming from bananas, access and control of resources, who is going to use the land for what. And this may slow technology uptake. So as CRISPR, we want to, the reason we are doing gender integration is to preempt this backlash in technology uptake. So for us to be able to achieve this gender integration, we have engaged in gender training, and we want to thank and appreciate VIB for co-funding the gender training activities. So we take the farmers through, and the stakeholders, not just the farmers, the extension workers, the administrators, the farmers themselves, the consumers, and we take them through gender training, practical gender training sessions. We also observe issues of gender on the farms, and usually and also just to give an incentive to the stakeholders, we usually give them a certificate at the end of the training. And in this respect, we also appreciate Danny Cohen, who has been very instrumental in, giving us technical backstopping and assisting us, in the training programs and the farmer outreach programs. So as I said, the farmers usually get a certificate, and this keeps them motivated to remain in the project. And the other major, hello?
Yes, 1 minute, please.
Okay, the other major component of the CRISPR project is capacity building in terms of good agronomic practices, disease detection, and we also have a graduate student that we are training under the project. We have also publicized the project quite a bit through the university newsletters, through webinars, through local press, and also we are happy that through VIB support, our student, who is our MA student, has also been trained on how to make to present with power, to make good scientific presentations. Just to finish, I would like to say that our sustainability plan is to, at the end of CRISPR, we would like to see a model demonstration farm and greenhouses, one per county. We want to also identify entrepreneurial opportunities for our participating groups through on-farm greenhouses, value addition opportunities, to further enhance public-private partnerships, to sustain the project, and hopefully we can have a bigger collection in our lab of the cooking banana, the naritas, the plantains, And recently we are talking about bringing in improved sweet bananas. And also we want to train the farmers on macro propagation so that they can access planting material. So I would like to finally acknowledge our father, the European Commission to do the RIP agree, and the Ministry of Education, the VIB, as I said, for co-funding, the university for supporting our work, our CRISMA partners, our research and field assistants, and all our stakeholders and other partners, including IITA and Alliance for Science. And I dare say that Alliance for Science has been instrumental in training us on how to make good presentations and how to publish, how to engage with all stakeholders. In Kenya, we say asante for thank you very much for listening.